Here is the next example. In this example, he's asking us to find the Thevenin equivalent circuit, okay, between AB terminals. Sometimes you might have some load resistance between these two, saying that RL equal to, say, another 2 ohms or something like that. They'll say find the Thevenin equivalent circuit across that 2 ohm resistor. For time being, I'm going to start with a load resistance with 2 ohm resistor. Okay, so step 1, there are 4 steps to solve this example. Step 1, remove that RL and open the terminals. Keep them open, so we're not going to connect anything between AB terminals. Okay, so that's our step 1. Now our goal is finding Thevenin equivalent circuit between AB terminals. So in step 2, find VAB. That VAB equal to VThevenin. That's our goal. VThevenin equal to how much? So here VThevenin equal to VAB, which is VA minus VB. So as long as I find VA minus VB, we're good to go. Now I'm going to ground this. So let me take that as 0 volts. So can I use the current division rule? So here is 8 amperes. 8 ampere is going to come over here. Now I'm going to use the current division rule. So let me take this as IX and current here is IY. So based on the current division rule, I mean these two are in series 60 ohm, these two are series 60 ohm. So current is going to divide equally since both resistors are equal. But simplification purpose, I'm going to use the current division rule. To understand it better, I'm going to use the current division rule. So IX equal to total current multiplied by opposite resistance over total resistance. So total is 50 plus 10 plus 20 plus 40. So you will end up with Ix equal to 4 ampere. You can say Iy is also 4 ampere by using the same theorem or same principle. Okay, current division rule. Let me write it down, current division rule, so it's easy to understand. So you have 2 resistors. So current division rule is valid only for 2 branches. So in this branch I have 2 resistors, in this branch 2 resistors, doesn't matter since both of them are in series. Okay, so this is valid only for 2 branches. As long as I know I total, to find I1 equal to total current multiplied by opposite resistance over total resistance. This is my current division rule. So by using this rule, you can find currents in each branch. As I mentioned, this is valid only for two resistors. There is one more formula if there are more than 2 resistors in parallel, but it's too difficult to remember. I want you to remember this though. Okay, now here my goal is not Ix and Iy. My goal is finding VA and VB. Okay, to find VA, what I'm going to do, since I know the voltage at this point as 0 volt, can I say the voltage across this as VA, and similar manner can I take this voltage across VB? We can do that. So VA equal to 50 times 4 amperes, which is 200 volt, and VB equal to same thing, 40 times 4 ampere, which is 160 volt. So what is VAB? VAB equal to VThevenin equal to VA minus VB, which is 40 volt. That's my VAB. Now step 3, we're going to find RAB. Find RAB. RAB equal to how much? So while finding RAB, if there is an current source, replace it with open circuit, because internal resistance of a current source is infinite. if there is a voltage source, replace that with the short circuit. So here I have a current source, so I'm going to replace that with open circuit. Okay, and here is my circuit, rest of the circuit diagram. Here is my A, B. Now I need to find resistance between A and B. So I'm going to redraw the circuit. So start from A, there are two paths. This is 10, 50, 10 ohm, 50 ohm. Now that 50 ohm is in series with 40 ohm. So this is in series with 40 ohm because there is no current flowing in this direction. So I can say 50 and 40 here, these two are in series. Same thing here, 10 and 20 are in series. So when I redraw the circuit, here is my A and B. So I can say 30 parallel with 90 ohm. That equal to 90 times 30 over 120.